Hi friends, welcome to Talent Sprints Banker's Choice program. In this session, we are going to discuss about directions. Directions is a very interesting topic and the questions here can be solved in a very simple way. Basically, we get only two types of questions where we either need to find out the distance between the 2 points or the direction of one point with respect to the other depending on the movement of a person. To solve such type of questions, the one thing which we need to understand very properly is the direction sense. So let us first look at the various types of directions we have. The four basic directions we have are as shown here. They are north, east, south and west. These four directions are called as cardinal directions. Assuming that a person is standing at this point, the direction towards the top is called as north, the one which is at the bottom is called as south, towards the right of the person is east and left of the person is west. The angle between any two consecutive directions here is always 90 degrees. As the angle between any two consecutive directions here is 90 degrees, that is the right angle, we can understand that for a person to change his position from one direction to the other in a consecutive manner, he has to rotate through an angle of 90 degrees. For example, when a person moving towards north has to change his direction to the west or to the east, he has to rotate by an angle of 90 degrees towards his left or right respectively. Similarly, when a person is moving towards west, wants to change his position to north or south direction, he has to rotate by an angle of 90 degrees. Apart from these four cardinal directions, we also have four intercardinal directions. Each of these intercardinal directions lie between the two cardinal directions. So let us now look at the various types of intercardinal directions we have. The four intercardinal directions are as shown in the figure here. Now, as you can see, the directions which lie in between the two cardinal directions are called as intercardinal directions. For example, this direction is between north and west. So this can be taken as northwest. The one which is in between south and west is taken as southwest. This direction is between south and east. So this is taken as southeast. And this is between north and east, so it is taken as northeast. So these are the four intercardinal directions that we have, that is northwest, northeast, southeast and southwest. One important point to be noted here is, as per the conventions, for each of the intercardinal directions, north or south should come first, followed by east or west. For example, this direction can be called as northeast, but it cannot be taken as east to north. Similarly, the remaining three directions are given in such a way that south or north appears first, followed by west or east. So always this should be taken as southeast but not east-south. And similarly, this should always be read as southwest but not west-south. And this should be taken as northwest but not west-north. After learning about the various cardinal and intercardinal directions, let us now look at how to decide the left or right of a person when he is moving towards a particular direction. For example, let us assume that a person is moving towards north. Now when this person moving towards north takes a left turn, it should be towards our left on the paper. So this can be taken as a left turn of a person who is moving towards north. Similarly, when this person moving towards north takes a right turn, it comes on the right of the paper. So whenever a person is moving towards north, left of the person is towards our left on paper and right of the person is our right on paper. But when the person is moving towards south, that is in this direction, his left and right will be opposite to our left and right on paper. Let's say the person moving towards south takes a left turn. Now that left turn will actually be towards our right. So when a person moves towards south, his left turn should be taken towards the right side of the paper and his right turn should be taken towards the left of the paper. Similarly, when a person is moving towards east, the left and right of the person can be taken as follows. Now a person moving towards east, when he takes a left turn, he actually starts moving towards our top on the paper. So his left turn should be taken on top, and the right of a person who is moving towards east direction come towards the bottom of the paper. So this should be taken as the right turn of a person moving towards east, and quite opposite to this will be the left and right of the person who is moving towards west. Let's assume a person moving towards west takes a left turn. His left turn will be towards the bottom of the paper. So left of the person moving towards west should be at the bottom, and the right of the person should be on top. So this direction sense of left and right is also very much required for solving questions from this topic. Instead of memorizing all the left and right sides for a person moving in any of these four cardinal directions, one simple way to do that is, whenever a person moves in any of these particular direction, assume that we are actually moving there and just find out what will be the left or right. Is it on top of the paper or bottom of the paper, or left or right of the paper? Let us now take the first model from directions, where the movement of a person from starting point to the destination is given in the question, and we are supposed to answer questions based on that. Let us look at the question here. A vehicle starts from point P and runs 10 kilometers towards north. It then takes a right turn and runs 15 kilometers. It now runs 6 kilometers after taking a left turn, and it finally takes a left turn, runs 15 kilometers and stops at point Q. And based on this movement, we need to answer the following questions. The first question here is, how far is point Q from the point P? Second question is, in which direction was the vehicle moving before it stopped at point Q? And the last one here is, in which direction is point Q with respect to the point P? To solve all the given questions, we need to trace the movement of the vehicle as given in this information. And that can be done as follows. The first point here is, a vehicle starts from point P and runs 10 kilometers towards north. So let us assume that this is point P, that is the starting point of the vehicle, and it has moved 10 kilometers towards north. We very well know that north should be on top here. So the vehicle moves in this direction, and it covers a distance of 10 kilometers. After covering a distance of 10 kilometers, it takes a right turn and runs 15 kilometers. Right turn of that person will be towards right on the paper. So now the vehicle has changed the direction towards right, and it runs 15 kilometers. So let us assume the vehicle covers now a distance of 15 kilometers, and it stops at this point. After covering this 15 kilometers, it now runs 6 kilometers after taking a left turn. Now if you can observe here, the vehicle is moving towards the east direction, and it runs 6 kilometers after taking a left turn. As we have already discussed, when a person is moving towards east, the left of the person should be towards top. So vehicle now has turned towards top, that is in the north direction, and it has covered a distance of 6 kilometers. After stopping at this point, it finally takes a left turn. Now vehicle now is moving towards the north direction, and it now takes a left turn, that is left on the paper, and runs 15 kilometers. So the vehicle now takes a left turn and runs 15 kilometers. This distance is 15 kilometers. And finally it stops at point Q. So this is the stopping point, and it can be taken as the point Q. So as given in the question, we have traced the movement of the vehicle as shown here. The vehicle starts from point P, runs 10 kilometers towards north. Then it takes a right turn and runs 15 kilometers. Then it takes a left turn and moves 6 kilometers. And finally again it takes a left turn and runs 15 kilometers and stops at point Q. And after doing this, we can answer the given questions. The first question here is, how far is point Q from point P? That means we are supposed to find out the distance between point Q, that is the stopping point, and point P, that is the starting point. As we can see here, the distance between point P to point Q can be taken as 10 kilometers plus the distance between these 2 points, and that is nothing but 6 kilometers, because these two are parallel to each other. So the distance here is given as 6, so this can also be taken as 6. So overall, the distance between point Q and point P can be taken as 10 plus 6, that is 16 kilometers. So the answer for the first question here is 16 kilometers. The next question is, in which direction was the vehicle moving before it stopped at point Q? So we are supposed to find out the direction of the vehicle before it had stopped at point Q. Very clearly, before stopping at point Q, the vehicle was moving in this direction, and this is nothing but the west. So we can say that the vehicle was moving towards west before stopping at point Q. So the answer for the second question is west. And the last question here is, in which direction is point Q with respect to point P? So we are supposed to identify the direction of point Q with respect to point P. Now to solve this question, let us assume that we are standing at point P, and now if we observe, point Q is towards the north of point P. As to reach point P, we have to move in the northern direction. So we can say that the point Q is towards north of the point P. So the answer for the third question here is north. Remember, while solving these type of questions, we need to be a little careful. Why? Because if the point P and Q are interchanged in the question, the answer also gets changed. For example, if the question is, in which direction is point P with respect to point Q, then we need to assume that we are standing at point Q, and then P becomes towards the south of point Q. So in that case, the answer would be south. So be careful whether the question is point Q with respect to point P or point P with respect to point Q. So mostly in bank exams, we only get these type of questions which can be very easily solved by tracing the movement of the person or the vehicle. Let us now take the second model from directions. In certain questions from this topic, Pythagoras theorem needs to be applied to get the answer. So before taking up an example, let us understand what is Pythagoras theorem. Pythagoras theorem is applicable for right angle triangles. In a right angle triangle, that is, one of the angles is 90 degrees. The side which is opposite to right angle is called as hypotenuse. Now assuming that the length of these three sides are A, B and C as shown, as per Pythagoras theorem, the hypotenuse square should be equal to the sum of the squares of the adjacent sides. That means C squared should be equal to A squared plus B squared. Or we can say that C is equal to root over A squared plus B squared. So this point will be useful in solving certain questions from directions. Let us now take an example based on this concept. The question is, a person started moving towards west and stopped at point P after covering 10 kilometers. He then takes a right turn and stopped at point Q after covering 12 kilometers. Finally, he takes a left turn, covers 6 kilometers and stops at point R. What is the distance between the starting point and the stopping point? So here again, the movement of a person is given to us, and we are supposed to find out the distance between the starting point and the stopping point. So as discussed earlier, let us first trace the movement of the person as given in the question. The first statement here is, a person started moving towards west and stopped at point P after covering 10 kilometers. So let us assume that this is the starting point of the person. And as given in the question, the person moved towards west and covers a distance of 10 kilometers and stops at point P. So this point can be taken as point P. And this is the starting point of the person. Now after stopping at point P, he takes a right turn and stopped at point Q after covering 12 kilometers. So from point P, he takes a right turn. Now as we know that he is actually moving in the direction of west, right turn would be towards top on paper. So he takes a right turn, that is, he now starts moving towards north and covers a distance of 12 kilometers. So let us assume this distance is 12 kilometers. And stopped at point Q. So this point can be taken as point Q. Finally, he takes a left turn. Now as we can see, the person is moving towards north and he takes a left turn. That is nothing but left on paper. And covers a distance of 6 kilometers. So he takes a left turn, covers a distance of 6 kilometers and stops at point R. So he finally stops at this point R. What is the distance between the starting point and the stopping point? So the starting point is as shown here and the stopping point is the point R. And we are supposed to find out the distance between these 2 points. As you can see here, the distance between the starting point and the stopping point can actually be obtained by making a right angle triangle. So assuming that this is the right angle triangle, the distance between starting point and the stopping point is nothing but the length of the hypotenuse. So we can say that the distance between the starting point and the ending point can be obtained only if we know the other 2 lengths of this right angle triangle. Assuming that the distance between the starting point and the ending point is C, this length is A and this length here is B. So C can be calculated only when we know the lengths B and A. Now A here is nothing but 12 kilometers as these 2 lengths are parallel to each other. So A will be equal to 12 kilometers and B is nothing but the total length from starting point to the point here. And that can be taken as the sum of 10 kilometers plus 6 kilometers as these 2 lengths are parallel to each other. So B will be equal to 16 kilometers as it is the sum of 10 plus 6, 16. Now, by applying Pythagoras theorem to this right angle triangle, we can say that C squared should be equal to A squared plus B squared. And A here is nothing but 12. So 12 squared plus 16 squared since B is equal to 16. And this total comes out to be 144 plus 256. So very clearly C squared is equal to 400. And from this we can say that the length C will be root over 400, that is 20. And as the units given are kilometers, this can be taken as kilometers. So we can say that the distance from starting point to the stopping point R will be equal to 20 kilometers. So friends, this is how Pythagoras theorem can be applied in certain questions to get the distance between the 2 given points. Let us now take the third model from directions, which is based on finding out the direction between 2 particular towns. The question here is, town D is to the west of town M. Town R is to the south of town D. Town K is to the east of town R. Town K is towards which direction of town D? So we need to find out town K is towards which direction of town D based on the given information. So let us just mark the positions of these towns as per the given directions. The first statement here is town D is to the west of town M. So let us assume that town M is in this position. And as given, town D is to the west of town M. And west of town M should be towards our left. So taking town D towards the west of town M, as it is the west of town M. Town R is to the south of town D. The south of town D is nothing but towards bottom of D on paper. So we can say that town R is in this position, that is towards the south of town D. And finally it says town K is to the east of town R. East of town R is nothing but towards our right, that is east of town R. So town K can be taken at some point towards the east of town R. So these are the 4 towns as given in the question, that is town M, town D, town R and town K. Another question is town K is towards which direction of town D? That means town K here is in which direction of town D? As you can observe, when we try to reach town K from town D, we have to move in this particular direction. And as this comes in between the south and the east of town D, this can be taken as southeast. So we can say that town K is towards the southeast direction of town D. So this is how we can simply mark the given positions of the towns and find out the direction of one town with respect to the other town. One point which I would like to make clear here is the distance between two towns in any of the cases is not given in the question, and hence we are simply taking them at certain distances. Irrespective of the distances between the two towns, town K will always be towards southeast of town D. So we can say that town K is towards the southeast of town D. Let us now take the fourth model from directions, which is based on the shadow of an object or a person during different points of time in a day. To solve questions based on shadow, we first need to understand the pattern in which the direction of shadow changes from morning through the evening as the direction of the sun changes. We all know that sun rises in the east, that is, during morning time the sun is in the east, and always the shadow of an object falls on the opposite side of the sun. That is, when the sun is in the east, the shadow will be on the west, and when the sun is in the west, the shadow will fall on the east. So during morning, that is before noon, when the sun is in the east direction, its rays falls on the object and the shadow falls on the opposite side, that is in the west direction. So this is the shadow of the object before noon. And as earth rotates and the day passes, the sun appears to change its position from east to west. At exactly 12 noon, the sun is always on top of any given object. Therefore, the shadow doesn't exist, or we can say that the shadow is exactly under the object, which is hardly visible. But as the sun moves towards the west after noon, the shadow falls on the east. So this is the shadow of the person or the object after noon. That is, when the sun is in the west, shadow will be in the east. So we need to remember one point here, that the shadow and the sun are always on the opposite sides. So during morning, when the sun is in the east, shadow should be on the west, and afternoon, when the sun is on the west, the shadow should be on the east. Now with this knowledge, let us try to solve a question based on this. The given question is, if at 3 p.m. the shadow of a person is on his right, then the person is facing which direction? So the simple point mentioned in the question is, at a particular time, that is 3 p.m, the shadow of a person was on his right, and from this point we need to identify the direction which the person was facing. In the given question, it is very clearly mentioned that the time is 3 p.m, that is afternoon. And afternoon, we know that the sun is towards west, and when the sun is towards west, the shadow of the object or the person should be towards east. So very clearly, if this is the person, his shadow should be towards east. Therefore, this is the shadow of the person, which is towards east. And in the question, it is also mentioned that the shadow of the person was towards his right, that is the right of the person. Now we know that the person's right is in the east direction when the person is facing north. So very clearly we can say that the person was facing north direction. So the answer for this question is north. Suppose it is mentioned that the shadow of the person is left. Therefore, we can understand that the left of the person is towards east. Why? Because afternoon at 3 p.m. the shadow is always on the east. So in that case, the left of the person is in the east. And as we have already discussed, when the left of the person is in the east, the person is facing south direction. So in that case, the answer should be south. But for the given question, the answer is north. So friends, these are the various models from directions that are asked in bank exams. Practice well on them. See you in the next session. Thank you.